Hi, friend. Welcome back. My name's Cameron Presley from Small Batch Solutions, and today I thought I'd mix up the video a little bit and actually do something I'm calling a code along. In previous videos, I've shown you how to do certain things, right? Like setting up a TypeScript app or how to iterate through union types. So small tips and tricks. But realize that we've never really sat down and solved an actual problem from beginning to end. And one of the things I always found about software engineering is not necessarily how this person, would solve the problem, but more along the lines of how do other people think about problems? And since I'm a big fan of functional programming, how do functional programmers think about a particular problem? So, to mix that up, we are going to tackle a small problem that my son actually brought to me and just show you how I would approach it. So, my son is 7 years old and he loves numbers. He loves math, but he wants to play some games related to math. Now, I'm from the generation that I grew up with Math Blasters, right? Like that was the game, but they don't really do that anymore. And plus, there's a big difference between playing it on like, the school computer versus a tablet versus smartphones, all that such. And to make things even more interesting, my son, even though he appreciates modern gaming, he actually likes a lot of the old classics. One of his favorite games is actually the original Legend of Zelda, right? With all of its pixelated glory. So I thought, hey, why don't we build out a simple console app for just doing basic math problems? And then, like in true product iteration, right, create an MVP, show it to him, and see what he thinks. So let's take a look at the requirements and what the MVP is. And then we'll just start breaking it down and code it out live. And that includes maybe I get stuck or having to look up something or anything like that. And that's normal. With that being said, let's dive in. The problem that we're trying to solve is that my son Jay wants to play a math game, and when I've talked to him, there's a couple of things that he wants to focus on. Right, so he's just started first grade, so he's not like used to negative numbers, multiplication, anything like that yet. So we're just going to stick with addition, and I really want to stick with just for the MVP numbers between 0 and 10. Right, so the biggest number he would have to get is 20, right? Because that's we're doing 10 plus 10. Now, like any good math guessing game, right, we need to give some feedback to show when his guess is right. We also need to show some feedback when the guess was wrong and also show, like, here's what the right answer was, right? That way, if he does get the number wrong, he's like, okay, that's why. And like any good game, we want to keep playing until they choose to quit, right? So this isn't like, oh, here's one math problem, that's it. It's like, no, we're going to keep playing until you're done, at least for right now. Once he plays with this, he might say like, "Oh, I want to do all this other stuff." So, with those requirements in mind, I could go ahead and just write some code on this, right? Like I could force something to work, but what I usually like to do is I like to start working on the domain. And so for me, domain modeling begins with the terminology. And the first word that catches my attention is this idea, this concept of a problem, right? So in our domain, a problem is a thing that needs to be solved, and that thing has two numbers involved, right? There's some restriction on what those numbers are, but that's really it. It has two numbers. So without writing anything else, I might go ahead and define this type. So I might say export type problem, and it's going to have a first number of type, first of number, and it's going to have a second of number. Now, the other thing that comes up from a domain modeling is that we have this idea, this concept of a guess. And then we also have this concept of an answer. Well, a guess, right, would look something like this. And that's fine. But since it's just mapped to a primitive, this doesn't make a whole lot of sense to type that out. And then same thing for answer, right? Answer is of type number. So kind of same thing. There's not really much to do there. So I don't really necessarily need to create domain models for those right now. But as the program gets more complex, I might need to. Now, one thing that I see new engineers make the mistake of is we've got this type of problem. And so you might be really tempted to do something like this where, oh, yeah, the problem also has a property or a field called number. Well, here's the issue with that. Let's say we come down here and I'm going to create a new problem. And I'm going to say the first number is 4, the second number is 2. right? And since we're only supporting addition, right, that's from our requirements, you would want this to be 6. But there's nothing really forcing me to do that, right? I've called it 6, but I could have also said it's 42, right? There's no compilation error. And the issue is the fact that the answer is really a computed property, right? It's this idea that if I know first and second, I know what answer has to be. So because of that, I could, make this a class, computed property, all that such, but that seems a little bit bloated. So we're just going to make this so we're just going to create a function and do that work. All right, so we can come down here and say export function, calculate answer. You give me some problem. I'll give you back a number, and we're just going to return p first plus p second. And now there's no way I can cross-thread this, right? Like there's no way I can give you back 42 because this is always dependent upon its inputs, right? So that's kind of the big thing. So just by doing a little bit of thinking and a little bit of like, how do we want developers to work with this? We've kind of already solved out our first requirement, which was, do we have a type of problem? Since index is kind of like our main entry point, I don't like this code sitting in index. So we're going to create a new file. We'll call it problem.ts. And then all I'm going to do is I'm going to yank all of this code and just shove it into problem.ts. Just like so. All right. Oh, so the next thing we got to do is we got to figure out numbers between 0 and 10. So since we don't always want to be the same value each time, we're probably going to leverage something from the math library in JavaScript TypeScript called math.random. So let's write a function. We're going to say create random, let's call it generate, random number, gives back a number. Now, if we go ahead and see what the docs from math random is and hover over, it tells us that random gives us some pseudo-ish number between 0 and 1. So that means it could be like 0.7, it could be like 0.22, it could be 0.11, it could be whatever. So I could return that, and let's actually console log this, right? So we're going to console log generate random number just to get some ideas here. And we'll go ahead and run the app with npm start. Right, so like that's the first random number, right? 0.39 and some repeating. And if I run this again, we should get a different number. We sure do. One more time, right? A little bit all over the place. I don't know about you, but I don't know very many 7-year-olds who would be able to add two of these decimal numbers together without running into problems. So one thing we can do to make that happen is we know that the number has to be anywhere between 0 and 1, and math.random could generate 0. So why don't we just take x and multiply it by 11? So if we do that, run this again, now we're getting numbers like 8, 2, 7, right? Like now we're actually getting whole numbers, but we still have a problem. And it's this fact that they're still decimals, right? We still have 7.35. We still have 3.49. That's not great. So what we're going to do instead is we're actually going to use math.floor to force the number to be the lower end. So if the number is between like 0.0, like 0 and then like 0.09, I think, or something like that, it'll floor it down to 0, so on and so forth. So if we now run this again, yeah, now we're getting numbers like 5, 4, 0, like we were just talking about, and 2. So this works, right? Generate random number works, but man, I hate this function so much. So right off the bat, one thing I don't like about it is what's the expected range. If I, as a developer, if I take a look at generate random number and I see number, it's not very clear, right? Like what's the low end? What's the high end? It's not great. So let's fix that. And before we fix that, and the problem is because we have this kind of hard coded, right? We have this 11, which is a magic number, right? So let's try a second approach for fixing this problem. So we're going to create generate take two. And instead of it taking nothing as inputs, let's give it a max. So we're going to give it a max input of number. And we're pretty much going to grab this exact same code. The only difference, though, is get rid of some of these comments. Now we are going to take whatever number you pass us in and pass in 11 in our case. Run this code again. Everything should work, right? We're getting 1, we're getting 4, so on and so forth, and that's great. But there's still kind of a problem with this code. Even though I said generate random number 11, it's not clear what that means. Is that the high end? Is that the low end? And why is it 11, right? Because I'm wanting numbers between 0 and 10. But 11 isn't one of those numbers. So this would almost look like a bug. So if I didn't know any better, I might come in and make this a 10. And now I will pretty much never get, I'll never get 10 as a possibility anymore. And that type of issue is also known as a fence post error, right? Or off by 1. They're kind of similar sides of the same coin. So I don't like this solution very much either for the reason we just talked about. So let's try a third time. So what if we took in a range, right? So we say generate take 3. We have a min of number and a max of number, and we return number, right? And we're pretty much going to take this exact same code again, except there's going to be a little bit of differences. So we've got x, which is just whatever math.random gave us, but we need to times it by not just max, but it actually needs to be max minus min, because that will give us the range, and then we need to say plus min. So this kind of works, right? So if we go back in here and say take 3, and we pass in, we want numbers between 0 and 10. Get rid of this comment, because that's now maybe no longer true. Right, we're getting 2, getting 3, getting some numbers here. Hopefully get something different than 2 and 3. There's 9. Right, so we're getting some numbers. This is a bit clearer because now I can read this saying like, all right, I'm generating numbers between 0 and 10. Okay, that works. But there's a subtle issue. What happens if I pass in the numbers in the wrong way, in the wrong order, like this, 0 and -10? Run the app again. Right, I'm getting -8, -6, -1. So far things are looking correctly. But if I were now to make this 30, so I want all the numbers between -10 and 30. See if we can get it to trip here. So far, so good, though. And let's see why that would be the case. So we are taking the floor of max, which is -10 in this case, -3, so it'd be -13, plus whatever the min is, so it'd be -10. So, sorry, max is -10, -3 is -13, so we're going to get some number between, we're going to get some negative number, we're going to add 3 to it. So I imagine we would never get a positive number, right? Because it's negative all the way through. And if we keep running this, that's what's going to happen, right? Is we're never going to get a positive number. Well, and the issue is because we flip-flop the order of this, right? It looks incorrect. So that's the problem. And also, this wasn't really ever designed with negative numbers, but our code allows it. So all sorts of problems, and why I don't like this solution either. Here's kind of a better solution. Instead of giving us a range, why don't you just give us a list of items that are valid? Now we're being much more explicit. So let me show you what I mean. What if we did this? We do export function generate take 4, where if you give me a bunch of items, number array, I'm going to give you back a number, or I will give you back undefined, because we have to handle the case that the array is empty. Now what we can do is we can generate an index. So we go, all right, well, we're going to say const index equals math.floor, math.random. This code should look super familiar to you. Items.length, right? And then we returned items of index. So we generate a random index and we index into that. Now let's take a look what that code may look like. So let's get rid of this, take 4. But now my items would look like 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Let's see here. Close paren, format, run the code. And now we got 4. Run the code again. We got the number 0. And this is actually a lot cleaner for a couple of reasons. Yes, we did introduce the idea that we could be undefined. There are some ways to handle that, but at least the type checker will help us out. But now we don't have to worry about, did you give me a valid number? Did you give it to me in the right way? Which items am I expecting? It's pretty obvious that you're going to be giving me something out of this list, especially if I fix up the name here. And there's also one more cool thing about this approach that I really like. This can be made generic, because take a look inside. Is there anything inside this code that is expecting that expects that the list to be numbers? This doesn't. The only thing it cares about is items and array. That's it. So there's no reason why we couldn't do this. Export function, choose item, takes in a T for the generic type. You give me an array of those T's, and I'll either give you back a T or something undefined, because maybe you gave me an empty list. I can take this exact same code, shove it in here, and knows how it type checks. No problem. So much so, in fact, I can come here, name this choose item, run the code, and it works just fine. That's pretty cool, right? The code's no more complex than what we had before. In fact, you could argue it's a heck of a lot easier to read than this nonsense, right? Where we're doing ranges and all that. And because of that, we can also control this, right? Because let's say I wanted this to always be a consistent number. Close the paren there, run the code. I should always get back 0, right? Because what else could it possibly be? So this could also be really good for testing things like that, which is kind of neat. So let's put that back, get rid of that, format. So we're going to burn all of this code away, because we don't care about that. And we're going to create, I'm going to create a new file, and I'm going to call this utils, because choose item is not specific to the problem at hand. It's literally just choosing an item. I don't like utils because it's kind of a kitchen sink name, because anything can go in there, but if I need to fix it later, I will. So we're going to take choose item, plop it in here, and that works fine. The issue, though, is we still need to be able to generate a random number between 0 and 10. That could go inside problem. So let's do that. So we can say export function, generate valid number, turns back a number, and this could return back choose item. Here's your valid options, right? 6, 7, 8, 9, 10. And let's say that choose item for whatever reason did give us that null. Cool, you're getting 0 back instead. That's your number. So even though this was saying this could fault, because I'm in this context of valid numbers, I could always give it that. I could also just tell TypeScript I know what I'm doing and just put a bang at the end of it. The difference, though, is that this would break if for some reason it gave null, whereas this one at least give you a reasonable default. From a developer perspective, it's kind of take your pick. So I'll leave the null coalescing, not null coalescing, null ternary. Forget the exact name. I'm going to leave this in here, long story short. And now we can come in here instead of choose item. This is get rid of all that. And I think problem, yeah, generate valid numbers, what we called it. Run the app, and now we're getting numbers between like 3, 0, so on and so forth. So that's cool. We've got that requirement figured. So now we're going to start working on guesses. But before we do that, we need to get a problem created. So I'm going to go back to problem, and I'm going to get rid of this bit. but we're going to export a new function. I'm going to call it create. And we're going to create a problem. And we say, cool, the first is going to be whatever generate valid number gives us. And then second is going to be whatever generate valid number is. Now we've got ways of creating problems. So let's just do a very basic UI and see what that look like. So we can get rid of this. We can say const p equals create from the from domain. No clue where that came from, so let's get rid of that. Bring in this import from problem. And then we can say console log string interpolation p.first plus p.second equals, and then just make sure our answer is correctly. We can calculate the answer of p, get rid of generate valid number import because we don't need that anymore, save the file, run the app, and we should be getting, like, yeah, right, 8 plus 4 does equal 12. And we can run this a few more times. 4 plus 4 does equal 8, right? So we're getting some different numbers and the math is looking correct. So far, so good. All right, so we need to show when the guess is right. That means we need to figure out some way of getting a guess, i.e. we need to get input from the user. So anytime I'm getting input from the user, whether it's from a file, keyboard, database, network calls, whatever, I like putting that in something called boundary, right? Because my boundary components are the very fringe and they are effectful, right? Because by definition, they're getting data out of nothing, right? They're getting outside of my system. So I want to make them very dumb, very thin as possible. I will put almost zero validation rules in there. Very, very, very few. So let's go ahead and create a boundary file here real quick. And it's literally just called boundary. And we are going to create a function called getInput. Terrible name, we'll figure out something later. Now, given the nature of Node, I know it's going to be an async function and it's going to be a promise of string, especially with the library I'm going to use. So I like using this library called Inquire Prompts. Super helpful. The docs are solid. There's so many stylistic things. Very easy to get going. Just love working with it. And I can go and show you. So if we did nothing more, we could say const choice equals input. It needs a config of some sort. The message can be blank. We need to await that and then return choice. And that's pretty much all we need to do. We've now got a very basic boundary. It's not doing any validation. It's not doing anything smart. We can come back to index and we can actually try that out. So we are going to say const yes equals get input. And we need to await that. Otherwise, we'll be stuck with a promise and we're going to log it. At this point, we've got a red squiggly. If I hover over it, it's saying like, hey, you can't use the wait at top level. That's fine. What we can do to fix that is just wrap this whole thing in an async function. So we can say async function main. It's usually what I call this. It's going to be a promise of void. Drop some curly braces, grab all of this, shove it in there, save, and then we just call main. And if we do npm start, we get 5 plus 7 equals 12. We're already getting a little bit of a question mark prompt down here, right? And then I can put in whatever. So we can say apples, and we get apples, and the app exits. So we've got, so we've got a way of getting input, but now we need to show when the guess is right. So from a UI loop, we would want to do something like const guess equals await get input. Get rid of this bit here because we won't show. And then we'd say if guess equals answer, calculate answer for p. We can say console log, you got it right. The issue though we're going to run into is a couple ones, right? Calculate answer is returning back a number because when you add numbers together, you get a number. But guess is a string. And even worse, if we take a look at get input, there's no validation happening, right? You can give me anything and it'll spit it back. And we want to make sure that you're giving us back a number from here. So we're going to thread through some validation logic. Now, you've got two ways you can do it. You can overload get input, and that's one way of doing it. The other approach, though, is I might do something like this. We're going to do export async function get guess. And notice how I'm calling this a guess, right? Because it's very clear what the intent is I'm getting a guess from the user. And we're going to say this is going to give you back a number. Okay. Now we can borrow a lot of the same code from before, but there is one more bit we need to do. And it's the fact that inquire prompts has this really cool other property called validate. And essentially, if you pass in a function that will validate your input, it will pretty much keep you stuck there if it's not valid. So for example, if we were to say validator equals, here's some string, and it needs to be as integer plus s. That's how we know if it's valid. Then we can say validate is the validator function, and then we can say return choice. Now, if I leave it as is, this is going to complain, so it'll say like, hey, you're trying to return back a string, but you said I'm a number. So we cheat, and we convert to a number by using the plus. Save the file. I'm going to come back into our index now. Instead of get input, we're going to say get guess. Notice how everything type checks. So let's get rid of our using, or import, we don't need that anymore. Format it, run the app. And we get 3 plus 2, right? And so if I put in 5, we get told you got it right. And if we do this again, and I'm going to put in 10, we get no output because we did not do an else block. So we got this requirement done. So let's do the else block. Else console log, not quite. The correct answer is, oh, I will fix that in a minute. So here's already where we're kind of doubling up on that calculation again. In this case, it's pretty cheap, so it's not the end of the world, but I'll show you a trick on fixing that in a moment. Calculate answer P. Let's see here. Yeah, I think that's it. So we run this again. Do you give us 6 plus 4? I give you 2. We say not quite, the answer is 10. Run it again. 3 plus 1 is 4. You got it right. So that seems to be doing good. And then if we don't want to calculate answer multiple times, let's say that was expensive, we can just do it once. You can say const answer equals this, so we're just extracting to a variable. If guess is equal to answer, you do that. Otherwise, here's what the answer is. The nice thing about using const is that we can't accidentally reassign it or blow it away or anything, so the odds of us misthreading that is pretty slim. Yeah, so far so good. We need to show when the guess was wrong what their answer was. Done that. The last thing we got to do is keep playing until quit is selected. So we're going to come down here and say console log. Want to play again. Press enter Q to quit. And that will kind of work. So let's run this. So we do an npm start. We'll do 11. And we're getting the prompt, but we need the loop. So we need to kind of keep track of some things. So we're going to do let should play equals true. We're going to do a do while loop here because you should at least get to play one time before we're able to quit. All right. Now, if everything works correctly, we should be in an infinite loop. So 10 plus 5 is 15. Want to play again, enter Q to quit. Yeah, so 13, 3, 11 to get it wrong. Not quite. So the loop's working, but we need to actually get some input from the user here. So we're going to say const, or actually we can do one better. So we're going to say const choice equals get input. We're going to await that. And then we can say should play is equal to choice to lowercase trim equals Q. And assign that. Kill the app, start this again. 0 plus 9, we can say that's 2. Not quite. The answer is 9. Perfect. Want to play again? Sure. Let's hit enter. Ooh, and we hit enter and we exited. And the reason being is because we've inverted this. This should be not equal to Q. Because we want to keep playing while the answer is not Q. So let's try that again. 3 plus 8, let's say 12. Not quite, answer's 11. We'll press enter just to keep playing. We get 2 plus 9, we'll say 11. Got it right. When we play again, let's hit Q. We exit. Perfect. So that's actually working pretty well. I don't like this bit though. This is kind of not great. So what I may do is go ahead and create, and the reason why I don't think this is good is because I've got some like UI parsing rules here mixed in with this. I kind of want it to be in get input, but I don't want to always put it in there. So let's go into get input and let's clean that up. So we're going to go to get input as a function. We're going to write a new one. And we're going to say export async function get should play. And we're going to return back a Boolean here. And we're going to grab pretty much the same code. No validator is needed here. The difference, though, is what we're going to do with that choice. So what we're going to do is we're going to say, all right, we got our choice, and we're going to say, well, if choice dot to lowercase dot trim, and we got a question mark all of this because it could be null all the way through, is not equal to Q. Now we've got that promise Boolean. Now, instead of getting this and interpreting the choice, we can get rid of the entire variable here, which is great. And should play is literally await get should play. Let's go down and run the app to see what we get. npm start 1 plus 9, let's say 10. Do we want to play again? We press enter. 9 plus 7, 16. So far, so good. Let's do 11 here to get it wrong. Not quite, answer is 12. Want to play again, enter Q to quit. One thing I don't like is it's kind of cluttering up my UI a little bit here in the terminal. So I want to quit. And we're going to do one more thing. We're going to do a console clear. Now we have 7 plus 4. Let's do 11. Do we want to play again, enter Q to quit, we hit enter. And notice how we've got kind of a nicer UI, right? It reset. And then we hit Q to quit. Yeah, and so let's clean up some things because we've got this requirement done, which was awesome. We don't need this import anymore, so we can get rid of that. And if we take a look at our code, it's not too terribly complicated, right? It's a simple app, I understand, but there's not too many business rules in here, right? The only business rules we've got, you could argue, is this bit, which we could extract out to a method, but I think that's a little bit overkill. Yeah, that's about it, right? Otherwise, it's just looping logic. Calculate answer, this would be a very easy thing to unit test. For create problem, you could unit test this by mocking out what generate valid number gives you, so that wouldn't be too bad. Generate valid number, this would be a really hard thing to unit test. You could use some property-based testing, though, to essentially make sure that you always got numbers between 0 and 10, but that's not exhaustive because random is random. I mean, if you wanted to, you could then mock what choose items doing, right? So you've got some choices there, but at some point you're getting diminishing returns. Just because there's not too many ways you could write this method. It would either always choose like the 0th item, or it would always return undefined because you don't know how long it is, right? So there's not too many ways you could really write an implementation. We already talked about problem. We already talked about the utils and boundary. I mean, you could unit test this, but I mean, there's not really a point because the minute you mock out the input function, right, that's coming from inquirer prompts, you don't really have any other business rules. It would essentially be like, am I converting this into a number correctly? Well, you'd about have to because there's no other way to implement the type signature. Boolean, this is probably the one you might want to think about unit testing just because you've got a little bit more business rules in here. But let's say you wanted to test this specifically, you could then just shove this logic back in the front end, like back in the index.ts. So I'm not totally, broken up by it. And just like that, we have a working game, right? Got all the MVPs, we've got all the requirements. And so for next steps is letting my son actually play it, right? And see how he likes it and what other changes he wants to make to it. Because a 7-year-old is very similar to a product owner, right? They have a big idea of here's what I want to do, and then once they start playing with it, they're like, hey, this is quite right, but not quite in other places, and we keep meeting somewhere in the middle. Though to be fair, my son probably has a little more sway with how I do my stuff more so than a product owner does typically, right? And with that being said, that wraps up this video. Let me know in the comments, right? How did you like this? Do you want more code alongs? If you're like, I don't know if this was necessarily my thing, I'd love to hear more from you. Until next time, this is Cameron Presley from Small Batch Solutions. See ya.